we have discussed some of the methods uh, in the list. One more method on the list is sublist. Just sublist is used to fetch a child list based on the index. Sublist method is used to fetch a child list based on the index. Yes, I am fetching the child list based on the index and I am printing. In any indexing mechanism, as we told earlier, from index is exclusive, from index is inclusive, to index is exclusive. Okay? The from index is inclusive and to index is exclusive. So 0 to 1. So it will fetch the elements from 0 to 1. Just list is the interface and we have not yet used list. Just I am importing list. It was compiled successful. Go to the classes. Execute the application. So, just this is the final list of list 1, Ravi 1, 2, and we are making a sublist of 0 to 2. 0 to 2 means 2 is exclusive, 2 minus 1, 1. 0 to 1. So, the first two values are coming into the sublist. So, this is how we can make a child list based on the index. Okay, we forgot to discuss that in the previous class. And yes. These are all the methods available in any list system, either list or a list or a vector or even a linked list. But the behavior of these containers will change from array list to vector and vector to linked list. But the methods are almost the same. Methods are 98%. The methods are same: add, all, remove. Okay, or retain all, contains all the methods are same. Okay, but the behavior of the containers will change from one list implementation to another list implementation. Okay, we have three list implementations. One is array list, vector and linked list, and moreover we should not keep the reference with the implementation. We should keep the reference with the specific interface. It's not advisable to keep the reference of the implementation. we should give the reference type as the interface. Just because if you want to change from one container to another container, we should change all the references, which is not correct. The reference should be of list type and the container can be any container. Okay, like it can be array list or it can be vector or it can be any other container, but the reference should be of the interface, the list type, so that we can easily modify from one container to another container. Or we can easily change from, or we can easily convert from one container to another container. So the reference should be of list type. Just standard. Okay, it's a standard that the reference should be of list type if we are pointing to any list container. And now the second container that we have is a vector. Vector is a list implementation. Vector is a list implementation. Vector is a legacy class. What are legacy classes means? The classes that are, or what are legacy entities means? The entities that exist from the very first versions of JDK. The entities that exist from the very first versions of JDK are called as legacy entities. So vector is a legacy entity. It exists from JDK 1.0 onwards. And vector is a synchronized object. Vector is a synchronized object. All the methods in vector are synchronized. All the methods in vector are synchronized. So, now, is vector thread safe? Is vector thread safe? Yes, vector is thread safe by default. Vector is thread safe by default. But vector gives less performance when compared to array list. Vector gives less performance and better security. Security in a multi-threaded environment. In a multi-threaded environment. When compared to array list. And the rest of the things, load factor or initial capacity or incrementation of capacity, everything is the same for vector and array list. Okay? And the major difference between vector and array list is vector is synchronized by default, but or vector is thread safe by default, but array list is not thread safe by default. That is a major difference. And the remaining differences are miscellaneous. Then what are the differences that you can list out for array list and vector? The first thing is thread safe. Okay, the first thing is thread safe. Vector is thread safe by default, but array list is not. Okay, this is the first difference. And the second difference is vector is a legacy entity, where array list is not a legacy entity. And third difference is in a multi-threaded environment, vector will give better security and very less performance. Okay, but in a multi-threaded environment, array list will give less security and better performance. Okay, those are the differences between a vector and array list. Understood? Now, except that everything is the same in case of vector and array list. Okay, now how we can make a array list thread safe? Okay, array list is not thread safe by default, but vector is thread safe by default, but there is a possibility of making array list thread safe. Okay, how we can make a array list thread safe means there is a utility class for collections named collections. Collection is a interface. Collections is a class. See, this is an interface. Collection is an interface, which is a root interface for collection API. This is an interface. Collection is an interface, which is a root interface for collection API, and collections is a class, which is a utility class for all the collection entities. This collections class has utility methods like searching, sorting, synchronization, like that. Utility methods means searching, sorting, synchronization, all those things. Collections is a class that has all the utility methods for collections. And collection is a root interface in collection API. Okay. Now, how we can synchronize a array list means just there is a method in the collections class which is named as synchronized list. Just we send, okay, the collection that we want to synchronize or the list that we want to synchronize to the synchronized list method, and it will return a list which is synchronized. Collections.synchronized list will take a list which is supposed to be synchronized and which will return a list which is synchronized. So this list 2 is synchronized, so that list 2 cannot be accessed by multiple threads at a time. Vector is not defined. Let me define a vector. This is not important. So this was compiled as well as executed successful. So now this list 2 is synchronized, and list 2 cannot be accessed by multiple threads at a time. Okay, this list 2 cannot be accessed by multiple threads at a time. This is how we can make an array list as thread safe. Okay? Now, the next one is linked list. Okay. Okay, just I have a class which is, there is a class which is linked list in case of list stream. Okay, and the linked list also behaves the same like other list components. Okay, but the exception property in linked list when compared to other list stream classes is, okay, the linked list will have a reference to the next and previous elements. Okay? Linked list will have a reference to the next and previous elements. So let's consider like zero index, first index, second index, third index. And zero index we have, hello. The first index we have high, the second index we have Ravi. Let's say third index we have, okay. So if this is a list, then what the arrangement happens is 0, 1, second, and there is no direct connectivity between 0 and 1 and 0 and 1. Okay, but in case of correlation vector, it is the same. There is no direct connection between 0 and 1, and 1 and 2, or 1 and 3. But if it is a linked list, what happens is, okay, the element in 0, okay, the 0th index, okay, has a link to the first index, and first index has a link to the second index. Second index has a link to the third index. Okay, and even in the vice versa also. Okay, in the reverse order also, second index has a link to the first index, third index has a link to the second. It is a double linked list. Okay, it is a double linked list, so that it has the links in forward direction as well as in the reverse direction. Okay, it has links in the forward direction as well as in the reverse direction. So let's consider like I want to insert one element in the middle. I want to insert one element in the middle. If you want to insert one element in the middle, what happens is just we break the link, and we establish a new link. Let's consider like okay. Now, how many elements we are changing, or how many positions that we are changing for inserting or removing an element in the middle? How many positions that we are changing, okay, for inserting or removing the elements from the middle? Now, recently I have inserted one new element in the middle. So, how many positions I have changed? Just I have broken one link and I have established a new link. So only these three connectivities are being changed. Understood? Only these three connectivities are being changed. I have broken the link. I have broken the link for the existing, and I have added a new element, and I have added a new link. Okay, I have added a new link between the first element to the second, second to the third, and then the reverse order. So, if there are frequent random insertions or random deletions, if there are frequent random insertions or random deletions, and we definitely go for frequent. Okay? Just because random insertions and random deletions are very easy in case of linked list. it will not shuffle the positions. Random insertions and random deletions are very easy in case of linked list because it will not shuffle the positions, just it will break the links. The positions are not shuffled. Okay? As I told, the positions are not shuffled because of random insertions or random deletions. Just the links will be broken and or the links will be added. The links will be added if we add a new element. The link will be broken if we remove an element. So only that particular link at that particular index will be affected. So if we have a list of 100 elements where we are adding or removing the elements continuously. So in case of array list, what happens? The positions will be shuffled. Let's consider like if there are 100 elements and if we are adding the element at the second index, what happens? From second to 100 the elements will be shuffled. Okay? Second to third, third to fourth, fourth to fifth, fifth to sixth, like that. But that shuffling is not required in case of linked list, just because it is a linking mechanism, and if we add an element at the second index, the link between first and second index will be broken, and a new element will be added at the second index, and a new link will be established from second to first and second to third. Understand? Okay, that's how the linked list will give a very better performance when compared to array list when there are random insertions or random deletions. And it is a double linked list. So the first element has a link to second, and in the reverse second also will have the link to first. Except that behavior, everything is the same. All the methods are same for linked list and array list. Except the specific behavior, all the methods are same. The interviewer may ask in any way, what is the difference between array list and linked list? What is the difference between linked list and a vector? Or what is the difference between array list and a vector? So, most of the guys what they will do is they by heart the differences, which is a worst scenario, which is the worst thing to do. We should not by heart the differences. We should know the properties of each and every container or each and everything, and comparing the containers we should frame our own differences. It's not at all correct to by heart anything, not even the differences, anything. We should analyze and understand the things, and based on that we should tell our views on the concept. Especially differences we should not by heart them. Definitions, yes, to some extent we can by heart them, but differences should not be by hearted. Just analyze the things. Analyze the first thing, second thing, and comparatively analyze the things and tell the differences. Okay? So, in case of collections, we have lots and lots of entities. So, if we go on by hearting the differences, it will be a waste of time. So, analyze the properties of specific entity and what is the specific property of each entity and what is the difference between entities. Okay?
How do we point to the next? How do we point to the next iteration without using the pointer?
Without using
Without using pointer, how do we point to the next iteration?
see, reference. In Java, to replace the pointer concept, we have references. Right? The next and previous are reference variables of type object class. So they can point to any object. Okay? There is no pointer concept in Java. But these reference variables internally uses pointers. But there is no direct pointer concept as per the Java syntax. But yes, even reference variables indirectly uses pointers. No. This is about the list stream, and there is another thing which is iteration of list elements. Okay, that we'll discuss after discussing set. There is a concept of iteration of list elements that we'll discuss after discussing set. And the next stream in collections is set stream. And set stream has different implementations like has set, linked has set, reset. Has set, linked has set, reset. And set stream will eliminate duplicate objects. Set stream will eliminate duplicate objects. That is a basic property of a set stream. Duplicate elimination by default. And how the set stream will eliminate the duplicate means, okay, it depends upon the equals and hash code methods. Based on the equals and hash code methods, okay, based on the equals and hash code methods, okay, the set stream will eliminate the duplicates. Now, let me have the first implementation has set. Just let me add multiple elements to the hash set. And let me add duplicates. Okay. Now let me print. Using the set stream classes also in the hash set, linked hash set tree set equals hash code method. Okay, two string method all are overridden. Okay, so now let me see how it will be, how the output will be. Okay, whether the duplicates are eliminated or not. Are the duplicates eliminated? Are the duplicates eliminated? Yes or no? Yes. Duplicate eliminated are eliminated. What is the order of insertion? First hello, hi, Ravi. Hello, hi, Ravi. 3 1 4 10. Is it in the forward order of insertion? Is it in the forward order of insertion? Is it in the reverse order of insertion? No. In case of hash set, okay, the order cannot be expected. It is a random order insertion. The order cannot be expected in case of hash set. Hash set has a random order insertion. So order cannot be expected in case of hash set. And one more thing, in case of search string, indexing will not be there. Set is not a indexed collection. Set is not a indexed collection. Set is not a indexed collection. Set is not an indexed collection. And so since set is not an indexed collection, all the index-based methods that we have discussed in array list will not exist. Like what are the index-based methods that we have in case of array list? Set, get, add at the index, add all at the index, remove at the index. All these methods will not be there in case of set. All the index-based methods will not be there in the set stream, just because set stream will not support indexing. And one of the index-based methods means add with index, add all with index, remove with index, set, get. All these methods will not be there in the set stream. Whenever a new element is added to the set, whenever a new element is added to the set, it will be verified against all the existing element, whether it is a duplicate of existing element or not, whether it is a duplicate of existing element or not. Okay, so like that, it will verify against all the elements. And how it will verify against the elements means, as we told earlier, based on the equals and hash code method. And hash set will allow nulls. Hash set will allow nulls. Let me add multiple null values. Hash set will allow null values. Okay, hash set will allow null values. Now, is null values are eliminated with duplicates? Yes, duplicates will be eliminated even in case of null values for a hash set. Okay, and even if you add multiple nulls, okay, only one null exists. But is that the case in case of array list? No. If you add multiple null values will exist. But in case of hash set, if you add multiple null values, only one null value will exist. Duplicates will be eliminated in case of null values. See, add method is overloaded in case of list. One method which takes a element and one method which takes a element and index. That method doesn't exist in set. See, we have in case of in case of list stream we have add which takes the object, okay, and another method add which takes the object and index. So it will insert that object at a specific index. This index based methods will not be there in the set stream, but this method will be there. Okay. And we can add multiple null values to a set. It will not throw any error, but multiple null values will be eliminated. Okay, as they are considered duplicates. And we cannot expect any order in case of hash set. That's for sure. Hash set will give a random order. Okay, but linked list will give you the insertion order, the order of insertion. Oh, sorry, not linked list, any list stream container or any list stream collection will provide the order of insertion. Okay, and let me have a class person. Right now we are using some library defined classes which are like hello, which is a string, 014 which is a double, 10 which is a integer. Okay, double wrapper class object and integer wrapper class object. Right now we are using elements which are of type defined in the library. Now let me use a class person which has ID, name, okay, and let me have a person constructor which takes ID, name, this dot name equal to name. Okay, We are memorizing a two-string method. ID and name. Okay. Now let me add some person objects to the list, to the set. Sorry, not to the list, to the set. Let me add the same person object to this. Okay. Now, what could be the size of the set? What is the size of the set now? Now, hello, hi Ravi. Now, are these three duplicate elements of the existing elements? So this three will not be inserted. Okay, so three. And are these two duplicates? Sorry. Are these two duplicates? Yes or no? It's a person object whose ID is 100 and name is Ravi. Again, it's a person object whose ID is 100 and name is Ravi. Now, will it be a duplicate or not? Will it consider to be a duplicate or not? Why? Why, Sharat? Why it is not considered to be a duplicate?
New objects are created.
See, if new objects are created, we consider object to be duplicates if the content of the object is the same. See, if new objects are created, addresses are different. But content is the same, right? We won't evaluate, object duplication based on the address. If the address is different, we won't consider them as duplicate objects, or if address is the same, we will consider the same object. If the content is the same, then the same object. If the content is different, then different objects. Even the objects has different address. If the content is the same, then we consider them as duplicate objects. Now here, whether these two are considered to be duplicate objects or not. These objects ideally they are duplicate objects. Ideally they are duplicate objects. But let us see whether the runtime environment is considered them as duplicate objects or not. Okay? If the runtime environment considers them as duplicate objects, what happens? Duplicate will be eliminated. Otherwise, two objects will exist. Now, is the runtime environment considering them as duplicate objects? Yes or no? No. How the runtime environment will evaluate two objects of the same class are duplicates or not? How the runtime environment will evaluate two objects of the same class are duplicates or not? By default it will evaluate the addresses. Okay? By default it will evaluate the address. How means? By using which method?
Hash code and equal.
By using equals and hash code method, the runtime environment will evaluate, whether two objects of the same class are duplicates or not. Okay, it uses the both equals as well as the hash code method to evaluate whether two objects of the same class are duplicates or not. So now we are using the object class equals method, right? See, in the person class, did we override equals and hash code method? In the person class, did we override equals and hash code method? No, we did not override the equals and hash code method. Only toString method is overridden. So it's using the hash code method and equals method of the superclass, object class. But hash code method and equals method of the object class will make use of the address. Just because the address of these two objects are different, they are not considered to be duplicates. But it's not the correct way. We should not evaluate the duplicates based on the address. We should evaluate the duplicates based on the content. So, if you want to evaluate something related to object based on the content, then we should override equals and hash code method. Definitely, it's a standard that we should override equals and hash code method for each and every model object. Okay? For each and every Java bin, we should override equals and hash code method. Okay? So, let me override equals. Okay? Sorry, not double equal to will not be there, will not work for strings. You should use equals. For primitives, we can use double equal to, but for objects, we should use equals. And we override the hash code method also. Understood? Do you remember how to override a hash code method? Do you remember how to override a hash code method? Just we convert all the non-string objects to strings and we execute the hash code method of string and we enter the hash value and we return the hash value. Now this is how we can override the hash code method. Okay? Now let's see. What happens? Definitely this will give you exception at the runtime. Missing return statement where at 46. Why is missing a return statement? Then 46. Where it is missing a return statement? So now is it eliminating the duplicates? See, Ravi is a string that we added first. If you see here, hi, hello Ravi. Hello is a string, hi is a string, Ravi is a string. Hello, hi, Ravi. Both are, all these are three strings. So with that, Ravi, hi, hello, only one combination is there. And 100 colon Ravi, it is a person object. Okay, just we are adding new person of something. Just we are adding new person of something. Okay, so this is how it will be. Understood? How the duplicates are being eliminated in case of such stream? By using equals and hash code method. Internally, to eliminate the duplicates or to evaluate duplicate objects of the same class. To evaluate the duplicate objects of the same class, internally, equals and hash code methods will be used. If the equals and hash code methods are not overridden, then duplicate will not be eliminated for that specific class. Okay? If the equals and hash code methods are not overridden, duplicates will not be eliminated for that specific class. So, now understood the purpose of equals and hash code method? Understood? So duplicate elimination will be done based on the equals and hash code methods. And set will not provide any order. Okay, it's a random order. And sorry, hash set. It's not set. Hash set will not provide any in order. It's a random order. And except the index based methods. Except the index based methods, all the methods in arrays are there in the set. Except index based methods like add of index or add all of index, okay, or remove of index or set and get. Except these methods, okay, like add index object, add all index object, remove index, set get. These methods will not be there in the set stream. All the index based methods will not be there in the set stream. Except that methods, all the methods, add all, which takes the collection, remove, okay, and we have retain all, contains all, trim to size, all the methods will be there in the set stream. Except the index based methods. And the next extreme collection is a linked hash set. Like a linked list, even a linked hash set will contain the references to the next and previous. Okay? Like a linked list, even a linked hash set will contain the references to the next and previous elements. So, the insertion order will be maintained in case of linked hash set. Sorry, linked hash set should be imported. We forgot to import that. Let me import even linked hash set. Okay, now the collection is not pointing to hash set. The collection is pointing to linked hash set. Now, is it following the insertion order? First, hello Ravi. Sorry, hello hi Ravi. Hello hi Ravi. And then I am adding a person object. Person object. So, is it following the insertion order? Yes. Linked hash set will give you the insertion order. The linked asset will provide the insertion order. And is random insertion possible in case of set? Is random insertions possible in case of set? Yes? Is random insertion possible in case of set? Yes or no? Yes? Write some code to insert randomly. Just tell some code how we can insert some elements randomly in a set. So if you are telling that it is yes, then you should know how to do that. Just tell how to do that.
This asset you follow the random. This asset you follow the random.
See, inserting randomly to a list or to a collection means at any point, like we have some elements, first element, second element, third element, fourth element. At any point we could able to insert the elements. Understood? See, random insertion means at any point we could able to insert the objects in the middle. Like if it is a list, then what we do is we can insert at the first index, second index, or third index, or fourth index. At any index we could able to insert the element. That is called as random insertion. Now, is that kind of random insertion possible in case of set? Can we add elements at any position? Is it possible to add elements at a specific position in case of set? Is it possible to add elements at a specific index or a specific position in case of set? It's impossible. In case of set, we cannot add elements as a specific index or a specific position. We should add, and the only thing that is possible is to add elements at the end. We cannot insert or delete elements randomly from a set. We cannot insert or remove elements randomly from a set. We should add at the end only. Just because if we want to insert randomly or remove randomly, we should have an index. But index is not there in case of set. So, random insertions or random deletions will not be possible in case of set stream. Random insertions or random deletions are impossible for set. Understood what is random insertion? Random insertion means at any point we should able to insert the elements. Like let's consider like we have here we have four elements in this collection. Okay? If it is a list, if you want to insert, you can insert element at this position, or you can this position, or you can this position. So, like this randomly we can insert at any position. But in case of set, that kind of random insertion at any position is not possible. We should insert only at the end. Okay? Understood? Understood? So, and what I told in the beginning is, for a set, the memory allocations will be done randomly. Okay? For a set, the memory allocations will be done randomly so that they are not continuous memory location. They are not in the continuous memory location. For a set, the memory allocation will be done randomly. That's what it is. But random insertion means inserting an element at any position. Say, we'll eliminate the duplicates. Understood? Now, the next thing is iteration. Iteration in case of a list and set. How we can perform the iteration in list and set? Iteration means accessing the objects through a loop. Accessing the objects through a loop. From a container. The container might be array, or a container might be array list, or a container might be a vector, or any collection. And one more thing that I forgot to discuss, I'll discuss later on. Okay. We can convert a list to an array as well as from an array to a list, that is possible. That we'll discuss in the next example. Okay. Now, in order to perform this iteration operation, okay, in order to perform this iteration, we have an interface in collection which is iterator. Iterator is an interface. We download util package, and using the iterator interface, we can iterate a collection. Using the iterator interface, we can iterate a collection. Now let us see what is iterator and how it will work. Iterator is an interface as we told, and we have a set. Let me consider that I am not adding any duplicate elements. Let's consider we are not adding any duplicate elements, but our intention is to discuss about how the iteration works. Let me add 4 person objects. Ideally, a list of set should contain objects which are identical. Let's consider like we have a list. We have a list of persons, list of employees, list of countries, list of states. Like that, a set of countries, set of states. Like that, any list or a set ideally should contain objects which are identical. The collections will give you a possibility that we can add objects of any type. But in a practical scenario, having a list which contain multiple which contain objects of multiple data type is a very less practical scenario. Okay, having a list which contains objects of multiple data types or objects of multiple classes is a very less practical scenario. A practical scenario is a collection which contains identical objects. List of persons, list of employees, list of departments, list of states, list of countries. Like that, any collection in general, in a practical scenario, okay, it will contain identical objects. Okay, but in case of list, at the compilation time, we could not at present, up to at this point, we could not able to restrict at the time of compilation that the list should contain only person objects. But there is a possibility of doing that using generics. While discussing generics, we can discuss like how we can enforce, like how we can set a rule that this set should contain only person objects. We can set a rule that this set should contain only person objects. But at present, we could not able to set that kind of rules without generics. But this set can accept any objects of any data type, objects of any class. But in a realistic scenario, it's not very practical to have a list or a set or to have a collection which contains objects of different classes. Objects will be of similar class in general. So, I have added 4 objects. Okay. Now, I want to iterate this set. If we want to iterate the set, we should have an iterator object. There is a method in the set with the name iterator. This iterator is a method in the set. In the list as well as set, we have iterator method. In the list as well as set, there is a iterator method. And this iterator method will return the iterator object. And the iterator object refers to the collection. See, set and list has a method iterator. Both set and list has a iterator. And the iterator method of a set or a list will return a object to iterator. Now what I told, iterator is a interface. If iterator is an interface, how you could able to create an object to this interface? How an object is created for this iterator interface? That will be a question from interface. You told that iterator is interface. And you are telling that using set.iterator or list.iterator, you are creating an object to iterator interface. But how it is possible? How it is possible to create an object to iterator, which is an interface? By making use of anonymous inner class. In the iterator method of a set, okay, how the code will be means, they will return new iterator object. Just let me give a scratch. In the iterator method of a set, this is the iterator method of a set, right? And the return type is iterator. And how it will be means? Okay. I am returning a new iterator object where in the iterator object they will override all the methods in the iterator. We have several methods in the iterator. Okay. So in this anonymous inner class, they override all the methods of the iterator interface. So this is how the iterator. So now, are we creating an object to iterator here? Is the iterator interface object created here? No. It is an object that is created for an anonymous inner class which acts as a subclass to this iterator interface. Understood how the anonymous inner classes are useful? Understood? So, here an anonymous inner class is used in case of iterator. Okay? And then, once iterator object is created, okay, we use a while loop. And there are two methods. Has next. The return type of has next is boolean. The return type of hash next is boolean. And hash next will return true until there are elements to iterate. Hash next will return true until there are elements to iterate. Hash next will return true until there are elements to iterate. So, once there are no elements to iterate, hash next will return false. And once the hash next returns false, while loop, what it will do? It will execute, okay, as a loop until this flag becomes false. Until this flag becomes false, while loop will be continuously iterating. Okay, so and there is another method which is next. Okay, there is another method next which returns the next object, and I am printing. Okay. This is how we can iterate the elements of a collection using a iterator object and the hash next and next methods of the iterators. Okay, now why we are typecasting this into a person means the return type of next is object. The return type of next is java.lang.object. So we are first typecasting it into a person. The return type of next is java.lang.object. Just compile. Let me go to the classes and let me execute the application. Now, how it is? Just it is iterating the elements. 100 Ravi, 200 Rajesh, 300 Srinath, 400 Prasad. Like that, in each and every iteration, a specific in the first iteration, first object. Second iteration, second object. Third iteration, third object. Like that, it is iterating over the collection. See, this is the collection 100, 200, 300, 400, and this iterator what it is doing? In each and every iteration, it is fetching first object. First iteration, first object. Second iteration, second object. Third iteration, third object. Fourth iteration, fourth object. Like that, for n number of iterations, it is getting all the objects present in that collection. This is how we can iterate over a collection using a iterator. Let me discuss in detail how the iterator works internally. Okay, now let's consider like these are the 4 elements present in the collection. Let's consider that these are the 4 elements present in the collection. Okay, 100, 200, 300 and 400, right? So let's consider like this is the collection. And there are 4 elements. Let's consider like 100, 200, 300 and 400. These are the 4 elements present in the collection. Okay? So, and how the iterator works internally means the iterator internally will have a pointer kind of mechanism. Okay, that's called as a iterator pointer. Okay, by default the iterator pointer will be pointing to element before the first. By default the iterator pointer will be pointing before the first element. Now, what the hash method will do means the hash method will return true if there are elements under the iterator pointer. Now, are there any elements under the iterator pointer now? Yes or no? Yes. There are elements. There are 4 elements after the iterator pointer. Now, there is a hash method return true or false? True. So, it's true. So, it is coming into the while loop. The while loop, what we are doing? We are executing the next method. The while loop, we are executing the next method. Okay, id dot next. And what the next method will do is the next method will do 2 work. First, it will fetch the object. It will fetch the object from the collection. Okay, id is 100, name is Ravi. So it will fetch the object from the collection and it will move the iterator pointer to the next position. Move the next method will do 2 things. The first thing is it will fetch the object from the collection, and the next thing is it will move the iterator pointer to the next position. Okay? Now, where the iterator pointer is pointing? To the first element. Okay? Now, let's consider that the iterator pointer is pointing to the first element, and now again the while loop will be executed. Now, if again the while loop is executed, now hash method will return true or false? Hash method returns true or false? True. Just because still there are 3 elements in the collection. So again it will come into the loop. Again it will come into the loop. And what is the next element? 200. So it will fetch the object from the collection whose ID is 200. Okay? And name is. And the next method given will make the iterator pointer to point to the next element. Now again, while loop will be executed. Okay? The while loop will be continuously executed until the condition is false. Now here, hash will return true or false? True. Just because there are still some 2 elements. Okay? And what the next method will do? The next method will fetch the object 300, 300, and the next method will change the iterator pointer to the next position. Okay? Now, again, we have written the element and we have printed the element. Okay? Again, what we do? Again, while loop will be executed as next. Will it return true or false? Will it return true or false? True. Just because there is one element. So again, it will come into the loop. We are executing the next method. What next method will do? Next method will fetch the element and it will move the iterator pointer to the next element. And we have retrieved the element to next and we are printing the element. Okay, this next method will do 2 things. It will fetch the element from the collection and it will move the iterator pointer to the next position. Okay, so now let me come to the next iteration. The next iteration, what happens? Hash will be true or false? False. Since the hash is false, it will come out of the loop. So all the elements are iterated and the iterated elements are being printed. So it is printing all the elements in the set. Understood? How the iteration will be there in the set? It's the same the iteration logic. The logic of iteration will be the same in case of list or set. In case of list or set, the same logic will be applied in case of iteration. Iterator interface, as next methods. Understood? All of you understood that how the logic of iteration will be happened? Internally, we will use the pointer method mechanism where the hash next will verify whether there are any elements under the pointer or not. The next method will do two things. First, it will fetch the element from the collection. The next thing is will move the eraser pointer to the next element. Okay? And if we have the iterator, once again, what happens? If we have the iterator, if we have the while loop, once again, what happens? This content will be printed twice or not. If we have the while loop twice, this content is printed because of the while loop. If I get this while loop twice, then is this content printed twice or not? Is that content printed twice or not? Why? Why it will not be printed twice? Because already this iterator pointer is pointing to the, because of the first iteration what happens? Okay, let's say we are having this while loop and we are having it. At the completion of this while loop, where the iterator pointer is pointing to, at which position it is pointing to? It will be pointing to the last position. Since it is pointing to the last position, if you go for the next while loop, what happens? If you go for the next while loop, what happens? Still, the iterator pointer will be pointed to the last position. The iterator pointer is pointing to the last position, what happens? Will it true or false? The first iteration itself, the first iteration of the second value, it will give false. So that only, it will be executed only once. Even we have 10 values, only first value will be executed. Okay? Now, we cannot bring the iterator pointer to the first position through the code. It's not possible. Using a iterator, we cannot bring the iterator pointer to the first position. It's not possible. Okay, so, can I tell the rule that using iteration, we can iterate a collection only once? Yes? Yes. It is a rule that using iterator, we can iterate a collection only once, that too in a forward direction. Using iterator, we can iterate elements of a collection only once, that too in a forward direction. Using iterator, we can iterate the elements of a collection only once, that too in a forward direction. All of you understood the usage of has next and next methods? All of you understood, right? What has next will do and what next will do? Has next will verify whether there are any elements after the iterator pointer or not. Next method will fetch the element from the collection and will point the iterator pointer to the next element. And other than has next and next, there is other method in the iterator which is remove. Other than has next and next, there is another method in the iterator which is remove. Has next, and even there is another method which is remove. Okay? We are executing remove method. Now, let me print the set before iterating and let me print the set after iterating. Let me print the set before and after iteration. So, Let's compile. Go to the classes. Execute the application. Now, before iterating, what is the set? This is the set before iterating. And after iterating, what is the set? Empty. But where the elements has gone? Where the elements? Why the elements got disappeared after iteration? Because iterator.remove will actually remove the element from the base collection. Okay? Iterator.remove will not remove the elements from the iterator. Iterator.remove will remove the elements from the base collection where iterator is pointing to. Iterator.remove will remove the elements from the collection where the iterator is pointing to. Iterator.remove will remove the elements from the collection where the iterator is pointing to. So what it is doing? It is fetching the elements. What next is doing? Next is fetching the element, right? After fetching the element to next, what I am doing? I will move the element. Next. So, at the end of the iteration, there is no element in the collection. Understood? Remove method of the iterator will remove the elements from the collection where the iterator is pointing to. So, at the end of the iteration, there is no element in the collection. And yes, if that collection is not used after the iteration, for better performance, it is better to remove the elements. Okay? If that collection is not used after the iteration, then it is better to remove the elements for the better performance. If you are not using the collection, then there is no use of the elements present in the collection. So, after iterating, just be removed for better performance. But make sure that that collection is not used after the iteration. The collection is used after the iteration, we should not remove. The collection is used after the iteration, we should not remove the elements. But if you assure that the collection is not used after the iteration, we should remove the elements from the collection so that it will give you better performance.
Though we don't remove, we can't use the elements. Though we don't remove, we can't use the elements. Then what the
see, though we don't remove, the elements will be present in the collection, right?
but
We can do, see, we have a JVM and JVM has a memory. Let's consider like we have a list of 100%. After iteration, we are not using the 100%. What is the use of persisting that? It's not useful, right? Okay? So, whenever the iteration is completed, we should remove the objects.
if we are using the user purpose, we don't remove it.
Yes.
Then what is the user? Already we should last position.
But we may use the list for some other purpose, right? We may not use the iterator for some other purpose. But we may use the list for some other purpose, right? The iterator is useless after iteration, that's for sure. But we cannot tell the list is useless after the iteration. So, we can remove the elements from the iterator using the remove method.
So can't I move the iterator pointer which is pointing to the last element back to the first element? Can't I move the iterator pointer which is currently pointing to the last element back to the first element? So that I can
No, it's not possible in case of iterator.
So where the remove function that's an iterator interface. The remove function.
Yeah, it will be there in the iterator interface only.
The interface function you need to do the definition to all.
Come once again.
If an interface contains something, you need to give the interface to, you need to give the definition to all the members.
Yeah, that is being done in the iterator method itself, right? In the iterator method of the set itself, the definition is given. So we need not to give the definition. Okay, just because we are not implementing the collection. Set is implementing the collection. So set has the definition in the iterator method to create the iterator object. That's what I told, right? In the iterator method of the set, okay, there is a code which resembles like this: return new iterator, where the methods are being overridden. Okay. Now, if I remove the object before executing next, it will be exceptional scenario. Okay. Okay. This is a illegal state exception. Okay. Why this illegal state exception means we are removing the objects before iterating, but before executing the next method, we should not execute remove. Remove should not be executed before next, just because only after accessing that element from the iterator we should remove the element. Otherwise, it will give a illegal state exception. It will give a illegal state exception if the element is removed from the iterator before iteration. If the element is removed from the iterator before iteration, if the element is removed from the iterator before iteration, then it will give a illegal state exception. So, remove method should be executed only after next. It should not be executed before next. Remove should be executed only after next. Okay? This is how the iteration works with the iterator. Understood? And the same thing can be applied even for list also. Just what I am doing is, in case of set and linked list set, I am taking a list, an array list. The same iteration mechanism will work even for list also. I did not change anything except that I have changed from set has set to list and linked list. Sorry, list and array list. So it will behave the same. So first in the list we have some 4 elements. We are iterating the list, and at the end the list doesn't contain any elements. So the iteration mechanism is the same in case of list and set. If you use iterator, if you use iterator, the iteration mechanism is the same in case of list as well as set. If you use iterator, the iteration mechanism is the same for list as well as set. Some people will call it as iterator. Okay, don't be confused. Okay. And then specific to a list stream, okay, specific to a list stream, there is another iterator which is called as a list iterator. There is another iterator which is called as a list iterator, which is specific to the list stream. List iterator is interface which is specific to the list stream. List iterator will not be there for the set stream, but iterator will be available for both list as well as set stream. But list iterator will be available only for the list stream. Okay, and list iterator is also interface, which is a sub-interface to iterator. List iterator is also interface, which is a sub-interface to iterator. List iterator is also an interface, which is a sub-interface to iterator. So even list iterator has all the methods. Okay, has next, next, and remove. So let me use the list iterator. In case of iterator, I use just let me. Let me use this to avoid the confusion. Okay. So now we have a list which contains 4 objects, and we are trying to get the list iterator object. To get the list iterator object, there is a method list iterator. Okay, the iterator method is inherited to list and set from the collection. See, we have a collection where list and set are implemented with the collection. And this iterator method is inherited from the collection interface to list and set. But the list iterator method is specific to the list interface. Okay? Iterator method is inherited from collection to list and set. But, sorry, the iterator method is inherited from collection to list and set. The iterator method is not specific to list or set. Iterator method is a method which is present in the collection interface, which will be inherited to list as well as set. But the list iterator method will be specific to the list stream. So it's present in the list interface. Understood? So list iterator is a method which is specific to the list stream. Okay? And it will return an object of list iterator. And the same thing will work out. Okay? The has, next, next, and remove will be there even for a list iterator. So a list iterator is interface which is in Java util package. We need to import that. Let me import that. So list iterator is there, it will be imported. It was compiled. Go to the classes and execute the application. So the same work is being done even by list iterator. But if the same work of list iterator is being done by iterator, what is the use of list iterator? If we are using a list iterator on top of iterator, means there should be some advantage of list iterator, right? So what are the advantages of list iterator? Okay, the first advantage of list iterator is, okay, the list iterator can be used to iterate the elements both in forward as well as in reverse directions. So we can execute the elements both in forward as well as reverse directions. We have additional methods. Okay, from iterator to list iterator, 3 methods are inherited. What are the methods inherited from the iterator? Means in the iterator we have 3 methods: has, next, next, remove. These methods are present in the iterator. Okay, and the list iterator extends or implements to iterator. Huh? List iterator extends to iterator or implements to iterator? You can go out of the class, man. No need to learn Java. Really and strictly. I told clearly that list iterator is a sub-interface to iterator. Between 2 interfaces, definitely it will be extends. Okay, and in addition to has, next, next, and remove, there are several methods specific to the list iterator. For the list iterator, has next, next and remove methods will be available. In addition to has next, next and remove, we have even has previous and previous. Okay, and there are some more methods we will discuss. Okay, has previous will be used to iterate the collection in a reverse direction. Okay, or iterate the list in a reverse direction, not the collection, list. Just because list iterator is specific to list. Has previous and previous are used to iterate the list in a reverse direction. Let me not remove the elements. Has previous and previous methods of a list iterator are used to iterate a list in a reverse direction. So, in case of has next and next, I am using even has previous and previous. Let us see what happens. Classes, just execute the application. Now what happens? Let me have a delimiter so that you can understand it better. Okay? What happened? Sorry. System. So, first we are iterating the elements in a forward direction 100, 200, 300, 400. And again we are iterating the elements in a reverse direction. Okay, so using a list iterator we can iterate the elements of a list both in a forward direction as well as in a reverse direction. Okay, now let's consider like I have commented this. I have given has previous and previous. Now will it print the elements? By default, for an iterator or a list iterator, what happens is the iterator pointer will be there at the before the first position. So let's consider like this is a list which has 100, 200, 300, 400, and the iterator pointer definitely by default will be before the first position. So now this is my iterator, list iterator or iterator. Whatever it will use the iterator pointer and it will be before the first position, both for iterator as well as list iterator. Now straight away I am explaining has previous. Now will has previous return true or false? False. So will it execute the value? No. So nothing will be printed in the value. So it will give false. So nothing is printed. The iteration is not done. So if you want to iterate the elements in a reverse direction, first we should iterate the elements in a forward direction. We cannot iterate the elements directly in a reverse direction. First forward and then reverse. So first if we iterate the elements in a forward direction, what happens? Okay? At the end of the forward iteration, where the iterator pointer will be? First position. Okay? Now it will execute has previous. Are there any elements previous to the iterator pointer? Yes or no? Yes. There are some elements pointer. So it will be like that. Okay? So as next or has previous. Okay? This has next will verify whether there are any elements after the iterator pointer. Has previous will verify whether there are any elements before the iterator pointer. Okay, but has previous will not, or has previous will return false until the iteration is done in the forward direction. Okay, we can iterate the elements in the reverse direction only once if the elements are iterated in the forward direction once. Without iterating the elements in the forward direction, we cannot iterate the elements in the reverse direction. Okay, so first forward, then it should be reverse. One forward and one reverse. So one forward and one reverse. That is possible. Okay. Just almost is the same like a bus route. Let's consider like we have a bus from HCU to Kochi. So if you want to make a trip from Kochi to HCU, first we need to make a trip from HCU to Kochi. Okay, one forward and one reverse direction. Okay, it's the same like that. And like this, we can have any number of forward and reverse iterations. We can iterate a list using a list iterator any number of times. We can iterate a list using a list iterator for any number of times. But it should be in a alternate forward and reverse directions. We can iterate a list using a list iterator. We can iterate a list for any number of times, but it should be only in a forward and reverse alternate directions. See, we can iterate a list even 100 times, but the iteration should be in an alternate forward and reverse directions. Even in list iterator, we cannot forcefully bring the iterator pointer to the begin or end. Okay? Even using list iterator, we cannot bring the iterator point to the begin or end forcefully. Okay? And while iterating the elements, we can add or remove elements to the iterator. See, in case of iterator, we can only remove, but we cannot add. But in case of list iterator, we can add elements. Final test. Now for each and every iteration it will be added. Okay. So let me go to SRC. So after the iteration what happens? 500 test, 500 test, 500 test and 500 test. It is added for each and every iteration. In the forward iteration, Ravi, Rajesh, son, 100, 200, 300, 400. So only 4 elements are there. But when it comes to the next while loop in the reverse direction, we have 8 elements. Just because for each and every iteration in the forward direction, we have added 1 element. So using a list iterator, we can add or even remove the elements from the collection. Okay? Understood? And when we use a list iterator and when we use a iterator, we use the iterator if the purpose is only to iterate the elements, not adding or removing. If the purpose is to iterate the elements in forward as well as reverse direction, and if you want to add some elements while iterating, then we go for list iterator. But otherwise, if our purpose is just to iterate the elements, we go for iterator only. Okay? But if our purpose is either to iterate the elements in reverse direction or to iterate the elements multiple times or to add elements while iteration, then we go for list iterator. Okay? And if the collection is set definitely we should go for iterator. If the collection is set, we should go for iterator. Okay? And then, what are the differences between iterator and a list iterator? Just list out the differences. List out the differences. What are the differences between iterator and list iterator? It's a very important question for interviews. As per your understanding from this class, list out all the differences. Okay? Understood? Now, just tell the differences. What is the first difference between iterator and list iterator?
Super interface of list iterator. Super interface of list iterator.
That should not be the first difference. The first difference should be list iterator is specific to the list stream, and iterator is generic for both the list and set stream. That should be the first difference.
It has only name address. It has relation to name address without phone address. Next tree yes, name yes.
Has
Then you don't need to iterate the elements in forward. That's for iterator. It's for both forwarding, reversing. Moreover, here we can only remove the elements. There we can add the elements.
The iterator is not known for person. Iterator is not known for person. Administrator or
okay. Those are the differences. Okay, if you have missed any differences, okay, those are the differences between a list, iterator and iterator. Okay, when we should go for a iterator and when we should go for a list iterator, that should also be mentioned in the differences. When we go for a iterator means the purpose is just to iterate the elements. If the purpose is to iterate the elements in forward or reverse direction or multiple times, or if you want to add elements to a list when iterating, then we go for list iterator. Even that should be added in the differences. Okay? And that completes the concept of iteration. Okay, that completes the concept of iteration in case of list as well as set. And tomorrow, not tomorrow. What I'm planning is Friday, Saturday, Sunday I have a planned vacation. So to compensate that, today and tomorrow I'll be taking even classes in the evening also. 8:30 to 10:15. 8:30 to 10:15, again 6:15 to 8:15. Tomorrow on and after. That is a schedule. Okay? Just adjust to that schedule for 2 days. Today, evening at 8:30 we have a class. And even tomorrow, at 6:15 we have a class. Sorry, at 6 we have a class. Okay? Tomorrow at 6 we have a class. Even today evening from 8:30 to 10:15 we have a class. Again day after tomorrow, even today evening as well as tomorrow evening. Day after tomorrow morning also we have a class. So we can compensate the holidays that we have. Okay? So within these days I am planning to complete collections as well as some more concepts. Okay? And today evening at 8:30 we'll discuss how we can sort the elements of a collection. Okay?